So, hello everyone. In this video, I'd like to talk to you about a concept called fine-tuning. I don't know if you've heard of it or not, but you can see how it's spelled on my screen. So, fine-tuning is the additional training of a model, teaching the model something specific. That is, you can take some model, for example, open or CLUD, it doesn't matter, any pre-trained model, and train it on some data so that it responds in the style, formality, or tone you need. In other words, the way you want it to. And in this video, I wanted to go into detail about what fine-tuning is, what it depends on, the quality of this fine-tuning, and how to actually apply it. We'll look at that in the next video. But in this one, we'll get acquainted with what it is. Oh, right. There will also be a comparison between fine-tuning and RAG systems. So in that case, which one should you use? Watch the video until the end. So let's continue talking about fine-tuning. And what's the most important thing you need to do, you might ask? It's to collect data. Without collecting data, nothing will work out. It won't even matter which model you use or how you train it. So data is the foundation of fine-tuning, the basis for improving the model's training. That means we first collect the data and review it. They have to be perfect. So, for example, question, answer, prompt, result. There's also the approach of structured versus unstructured data. Ideally, the data should be structured, cleaned of unnecessary junk, and perfect to get a good result. Once we have the data, we choose a model. In this case, it can be any model, one that's already been pre-trained. So, this could be an OpenAI model, Cloud CLUD, or some open source model. The whole point of this model is that it should already be trained on some data, ready for use, and all we want to do is improve it. In other words, we combine a pre-trained model with the data we have, specially prepared. We'll take a closer look at them in the next video. I'll show a real-life example of how you can train a model from OpenAI. So make sure to subscribe and leave comments if you're interested, so you don't miss the next video. Let's get going. So at this point, we've already got our data and we've chosen a model. Let's say it's a model from OpenAI, and now the training begins. Training means that we further fine-tune our chosen model. In other words, we tell it, in cases with these prompts, please respond in this particular style or format. And as a result, this takes some time, which varies depending on the amount of data, the model you chose, where you're training it, and the computing power you have. That is, you can do this locally, by renting a server, or by using some service. It might take 30 minutes, or it could take 3 hours. Again, if you have a large amount of data, the more data you have, the better the quality of the result. And in the end, we get a fully trained model that is available only to us. And of course, we can share it, but usually, if someone trains a model and spends money on it, they don't give it to anyone else. So now we already have a ready-made model, and now where can we use it? Let's talk about use cases. So, in what situations is it actually used, this fine-tuned model? It's very popular in areas that involve chats, bots, and all that stuff. So, if you need it to communicate or respond according to certain criteria or in a specific format, you can set it up in a particular style. For example, it's perfect for running public pages, right? So if you make posts based on some information and you used to write them yourself, you can train your model on those posts, and it will generate future posts in exactly the same style you used before. That's a very popular use case. The next use case is when you use a bot in some kind of business setting. For example, this could be lawyers, a construction company, or medical professionals. In those fields, there are specific terms. Maybe the model didn't know about them, or you wanted to use them more often than usual, or maybe use them less. And in that case, fine-tuning the model gives it an understanding of how it should behave when users ask certain questions. So, it should respond in a more in-depth way, using more technical terms, or more broadly and superficially, because the main audience might not be specialists in this topic. This is also a popular use case that I recommend to everyone and often use in my own projects. These first two steps, they probably make up about 70 to 80% of all the workflows I've built and used. They include these steps. And for the last option, I wanted to give you an example. This is CNN. If anyone doesn't know what CNN is, here we're talking about LM models that are good at communicating and understanding human speech or text. There are CNN models, which are mainly used for computer vision. That is, in situations where you need to recognize something in an image or on camera. And so, in the context of fine-tuning, you could say, for example, imagine we have a CNN model that is good at recognizing cars. What kind of car? The model. But it hasn't been trained, for instance, to recognize sports cars or race cars, because that's a specific area that isn't needed in everyday situations. But for some reason, we want to use it specifically to recognize sports cars. In that case, we can take this same pre-trained model and prepare the data. In this case, the data would be images of race cars, sports cars, sorted and labeled with what kind of car it is and which image corresponds to which car. So here it's very important that the data matches reality. So if you upload data that doesn't match reality, the results will be terrible. That's why a lot of time and resources are spent on structuring, preparing, and collecting data, because this is a very important and fundamental step. If it's done poorly, all the following steps will be pointless. So we've prepared the images. We've labeled them, Ferrari, McLaren, and all the other cars, sports cars that we're interested in. Then we started the training, and after that, the model will be able to recognize which sports cars are in the video or in the images. Here's another example, a case that fits for the model. So let's move on to the comparison now, as I promised at the beginning of the video, RAG or fine-tuning. Which one should you use? Let's go over fine-tuning. So you already know what fine-tuning is, right? Basically, it's additional training of the model. The data you use for training gets embedded inside the model. But when you use RAG, that's an external data source. So the data isn't embedded inside the model. Instead, it's stored elsewhere, like in a vector database, right? Or it could be some other system. But the model itself doesn't know anything internally about the data that's stored in RAG. And so you end up with two possible approaches. One approach is if you have a lot of data that rarely changes. Fine-tuning is a great option to train the model and then use it without RAG, for example. Or you can leave some data in RAG, especially the data that changes dynamically. RAG is needed when you're working with data that changes dynamically or when there's very little data. That is, training a model on a small amount of data is practically pointless. So in this case, it's better to use RAG. When it comes to cost, again, it depends on these two criteria, whether you have a lot or a little data, and whether it changes frequently or rarely. If the data changes often, retraining the model every time might not be economically viable. And if there's only a small amount of data, training a model on it is also pointless, because the result won't be very good, not what you'd hope for. But if you have a lot of data and it doesn't change often, then again, you train the model. That's it. Now it knows your business area perfectly, and you can use it without even connecting a RAG system. But again, in the next video we'll go over. I'll show a clear example of how to train a model and how you can use it without a RAG system, without any data sources, and it will already have that information. So once again, fine-tuning is basically sealing, so to speak, the data inside the model. So your model gets a new data source, and it will rely on that data source from then on. RAG is a great place for news, for example. Yeah, news comes out every day, and you upload it to RAG, and the model already uses that news. So I hope this video made it clear what model fine-tuning is. I hope everything is clear to you now. If something isn't clear, write in the comments. We definitely read them and reply whenever possible. Join our Telegram channel, subscribe to our YouTube channel, and give us a like. How often videos come out and what topics they cover will depend on this. Don't forget to leave comments, because I've noticed that a lot of people have stopped requesting future topics in the comments. Don't, this affects future videos. So be sure to write in. Also, you're welcome to join the Telegram channel, because there we discuss if people have any issues with technical questions that help guide them in the right direction. We discuss all of that there. Not a single message goes unanswered. So, see you in the Telegram channel. Be sure to stay tuned for the next video, because in the next one there will be a real example of fine-tuning, how to use it, how to train it. See you next time.